Okay, we're live. Nice.
Okay, cool. Hi, everyone. Good morning, good evening, wherever you are. And thank you for joining us on the fourth technical workshop of Polkadot Hackathon Asia Pacific edition. Today, joined with us, we have Alex, who's going to go through with you some of the best practice to take note of when you are building palettes, and he will go through some of the demos or some of the codes that you should avoid or kind of build along the way as well. And after the entire session, we will take some questions that you have in terms of building on the palettes. So feel free to drop your questions in your chat or ask a question, and Alex will answer them after his sharing session as well. Before we end off the day with some of a recap of the Polkadot hackathon matters, especially that we are close to submissions as well. So right now, I'll welcome Alex. Alex, the floor is yours.
Thank you. Thank you, Justin, for introducing me, and thank you all for having me. As Justin already said, I want to introduce sort of how to, so in some sense, best practices by showing worst practices. So that was a playful idea that we came up with a while ago. And I think can be very good, right, to see like, okay, this is how you don't do it, and then like this is how you do it, and contrast the two to get a feel for this. I'm a runtime / solution engineer at Parity, and sort of work with this stuff day to day, and sort of just threw a bunch of stuff together that I have encountered recently, or that I've thought about recently, or that I consider important. This does not cover all the best practices. So the example I have does not cover all the best practices. So if you're curious about something, feel free to drop a question. I very much encourage you to sort of ask questions and give comments to give me some idea of what I should talk about. Right? I don't know where everyone is at. So so do let me know, and I'm happy to sort of engage on whatever questions and confusions and things you might have. This for now, this will mostly cover Substrate development. I think we can definitely also cover some things that are more related to parachain development. That is not what I have already prepared, but I'm happy to talk about that. Sort of, right? You can use Substrate to build a parachain, or yeah, and some of the same considerations apply, and some are actually a little stricter than for just a Substrate runtime. So what I would start with right now is to go into the demo and start explaining some of the things that I will be covering. Let me see if I can share my screen. Okay, good. So what we have here, I think I have to reload this. Let's also share this. So I created a repo, how not to build a palette. And this is sort of the basis for what we'll be doing here. You can see the chain running here. And of course, the first thing that you see here already is already one of the things that I want to jump in. And that's okay. All right. So it's stalled, and I was like, oh god, it's stalled. But thanks for the naming praise. All right. So you can see here, maybe you saw that it said last block 2 minutes, right? And you will see in a moment that the chain will stall, and that is sort of on purpose to illustrate something. So we will cover a bunch of the best practices, and one of the best practices is to avoid unwrap in the runtime, basically at all cost. Right? So you might know if you've done some Rust development with Substrate by now, so you probably know that with unwrap you can get the inner value of an option or of a result. And oh, by the way, let me know if the typing's very loud. Then I'll have to see. What we can do about that if the noise is too high. So this is the template palette that I adjusted for this. And one of the things that you will notice is that it has a, okay, let's make this bigger. That's good, I think. One of the things that you will notice is that it has an onInitialize function. And you can see here that the last block has been a while ago, right, of the chain that I just started. And the reason why our blockchain is stalled now is because I did not keep to the best practice and I followed the worst practice. And that is you basically never, ever want to do unwrap within these hooks of uninitialize. And because basically because there are a lot of scenarios where parts of your palette might be called in someone else's uninitialize. So for example, there is a scheduler palette that allows scheduling calls at a later time. And the scheduler executes in uninitialize, right? So your call that might contain an unwrap might be called in this by the scheduler in uninitialize, so that it will be functionally the same as the terrible thing that I did here, right? Which is it tries to access some storage. This is the it's a storage getter that we have here. It's this one, right? It tries to access the storage per default. If the storage is empty and there's nothing in there, we will get an empty option, a none value. And when we unwrap an unvalue, the unwrap panics. And what that means in the runtime is that the runtime will basically shut down, right? So this is bad if it happens. This is bad if it happens in an extrinsic, but this is especially bad in uninitialize because it runs on every block, and so your chain will be stalled and will not be able to make progress anymore, because anytime that it tries to build a block, it will run into this and be stalled. All right, so right, this failed. Last block was 2 minutes ago. So let's see how we can fix that. We can do something about that by I built in a little bit of a timer implicitly, because this is a modulo check. So this is not always executed. So if we're fast enough, then we can do something about this. So what we'll do here is. So I reloaded because I restarted to make sure that it's connected in the right way, and then we will store something, and we will store 5 and submit the transaction, and then the value that's in storage will be this will be 5, right? And the unwrap will not trigger and will not sort of go bad. We should be able to see the something stored, and then once we hit our block number 9, I think it should be 9 plus 1 is 10, modulo 10 is 0, right? Then we will get this event from the uninitialize. This one, right? So we know it didn't panic; it worked. Right, this is part of the thing that's devilish about the unwrap. You might not always hit it, right? Which is why you should just not use it, except in sort of very rare circumstances where you know for a fact that there should be a value behind it. And then what you would do is you would not use unwrap, but you would instead use use an expect. I'm not gonna write it right now, but you would use an expect and then provide some comment of why this can never fail, and then if it does fail and you're screwed, then at least you know what went wrong. So yeah. All right. So this is the first big no-no. Don't use unwrap in the runtime. Except for very rare cases where you might want to use it is if you want. Do I want to go into this? So in case you want a block producer to not be able to build a block, this is a valid strategy for using unwrap, right? So if a block author provides some invalid data or something that tries to build a block that's dangerous, that might be a valid strategy, right? To keep the block builder from building this dangerous block. So if, for example, don't know, like this is a fictitious example. I'm not sure it's a perfect example, but if you had a mining functionality in your chain, and the block producer would just mine some tokens, and they could choose the amount, for example, right? And if they choose an amount that's too big, bam, it's invalid, and it panics. And if they choose an amount that's small enough, then it works, and then they can build the block like that. Maybe that's fictitious. I'm not sure that's actually good design, but that could be a reason for using this. All right, cool. So I spent a lot of time on this one thing, but I think it's good because it's really important, and it can easily slip in if you don't pay attention. Cool. So what are some other things, best practices that we want to keep to? So one of them is weighing. I actually took this template and I adjusted it, and I used the benchmark that was already there to benchmark this function and give it a proper weight. So if we look into, let's see. If we look into the weights file that I generated, this is on my laptop, right? This is not representative of what would run on a proper validator. You would have a file like this that's generated. There's a benchmarking. There's a bunch of benchmarking tools that Substrate comes with, and you can write a benchmark. Actually, let me also show. Let me also show the benchmark. So you would have a benchmark like this. There's a bit of macro stuff going on here. It would call the this calls the extrinsic, and then it will do this repeatedly to get fairly reliable execution data on how long it takes, and then it will generate a function like this that says, like, okay, when I executed this function, the parameter that you passed was irrelevant for the weight. Right, which makes sense if you look at the function. If you look at the function, the input is irrelevant for how long it takes. Right, the thing that takes time is accessing the storage and the ensure signed here and whatever. That's the stuff that takes time. So irrespective of what you pass as a parameter, that doesn't matter. There was some constant weight, some constant amount of time that it took. This is sort of a median, I think. Yeah, either the min squared or median value. We can go into details a bit more later, and I'm a bit hazy on some of them. But it sort of takes something like a median value, like a representative value for how long it took to execute that function, and then it registered that there was one write to the storage, and so that's there are some generic benchmarks for the underlying database that are run. And then based on these, we know, okay, the database weight for a write is whatever time, and then we can add those two together, the time that we took for our computation, sort of for our execution, and then the time that we expect the database to take to be able to do one write. And then we add those together, and we know roughly how long this function is expected to take on representative hardware. Representative hardware, in this case, being my laptop, because that's where I ran the benchmark, but of course you would use a proper benchmarking machine. So, generating these weights and building these benchmarks is best practice. Here the parameter was irrelevant in this particular case. I think it's fine that this benchmark passes it and has it as a parameter. I think you could leave it out because it's very obvious that it doesn't affect the result at all. It doesn't really matter. For a different benchmark, it does matter. And that's the thing that we will look at next. So you can see here benign repeat hashing, and we will now look at that family of functions. So we have to repeat hashing. So you can see that 10 million is sort of a similar ballpark as the 26 million that we had earlier for our benchmark. So that's why I put this value in case it's not a function is not benchmarked. That doesn't mean that it's fully safe, but it makes it somewhat hard to exploit, right? You have to pay some amount of fees to be able to execute this function. And right, so like a ballpark, you could say like, oh, maybe it's okay, right? But this function executes the do repeat hashing. And the do repeat hashing is going to be interesting for us, because what it does is, based on the number of the number that you pass in, it will do that many rounds of hashing, right? So it will take the account that sent the transaction, sent the extrinsic, and it will hash it the number of times that you specify in the function. And of course, you can easily imagine that the time that this function takes depends heavily on this variable. So even though we have a reasonable weight for a sort of a very small extrinsic, it disregards the fact that the complexity, the time complexity of our extrinsic depends on the parameter that we pass, right? And you can see, right, a dangerous, repeat hashing, benign, they're the same, and the only difference is in the weight, right? And this is sort of where I want to illustrate how important the benchmarking and the weighing is, because it can make the difference between your chain being safe and not safe. So now we will try this out, right? And we can do the dangerous repeat hashing, right? And we might put a number like 5, and we will submit. And then you saw the event here, right? And you can see the event here, right? This is the hash that we generated. And all seems fine, right? Like we called the function, worked all fine, all good. But now we can make this value 5. I think I tested it with these values. Let me see, 2000, right? And what you will see is, well, it's still fine. It works just fine. Then you might give a value like 2 million. And let's see, I think on my tests, I think that still worked, right? So maybe the block takes a little bit longer, but maybe it was fine. So now we start using really big values. You will see that the block time increases. We're not at 6-second block time anymore. We're also not at 12-second block time anymore. We're somewhere very somewhere else, right? So basically, unfortunately, you can't see the logging. If I go into the logging of the chain, I get, or do I? Let's see. Does it give a message? Yes. So I get this message. I'm going to just post it in the chat for you guys. This is the logging message I get if I look at the logs of my node. And what I get when I look at the last block here is it just increases, right? And it's sort of like, okay, it discards the proposal because the block took too long, the block production. So basically, because we didn't weigh our function correctly, we just stalled our chain again. You can see that the node is being shut down. That's why it doesn't connect. Because like now it's basically broken. It's stuck. Let's see. I think I might need to kill the node actually. I think it might be stuck. Right here. There, node template. There we go. Yeah, I had to kill. Did it crash the PC? So my PC didn't die. Mine didn't die. Mine is fine. You'll see in a second that it picks back up. I just had to kill the process. I think the process was stuck for me, and I had to kill it. I need to quickly store the thing again. Otherwise, we will get the other stall. All right, so that showed us that we can easily stall our chain if we do something dangerous, like not benchmarking this this function that sort of whose computation is linear in the inputs. How's the benign repeat hashing different? Well, it has it uses a weight and calculates the weight based on the input parameter that we give it. So to sort of demonstrate the benign repeat hashing, right? If we put 5, it's the same as it was earlier. But if we put a big value like 2 billion, it tells us, hey, the transaction would exhaust the block limits, and so we cannot put it in, right? And so then we can test, like, okay, what about 200 million? And like, oh, okay, it's also outside of the block limits. And what about 20 million? It's also outside. And then I think at 2 million, 2 million also exhausts. Okay, interesting. Yeah, okay. So at 200,000, it goes in fine, right? And so because we have this benchmark, it works, right? And so for now, I want to sort of go quickly into the yeah. Thank you. I found it very, very illuminating as well, right? It's like you can just see, like, okay, if you get the weights wrong, then you might just stall your chain. So the benchmark here is parameterized over this. I called it I, right? It's just a number of times that we do the repeat hashing. I picked the value of 100,000 because that seemed like a decent kind of thing. Also based on, right, my node stalled with big values over 2 million, so I figured, like, oh, with 100,000 it's fine, so that's what we pick. And then that allows the benchmarking to pick up the correlation. So what the benchmarking will do, actually you can see that in the resulting here, it will repeat and it will run steps. So what steps means is it will separate the values from 0 to 100,000 into 30 steps. So, oh God, I can't do the math right now. It's like 333 or something. No, 3,333. And then 6,666 and so on, right? It will do those different steps and it will run the function and it will measure how long it takes for each of those. And then it will do a bunch of repeats of that to make sure that it gets consistent numbers. And then based on that, we'll figure out that based on an analysis that it basically, I think, a regression analysis, it figures out that, like, okay, the parameter I is responsible for about 659,000 I think picoseconds is the number. So the number here is basically picoseconds of execution, if I remember correctly. Do correct me if someone remembers. We can look it up as well. But this is some sort of relatively small number of seconds, sub-second times, right? And so then the benchmarking function can tell us how long roughly our extrinsic will take based on the number that we put in. And so then the substrate, right? We tell it, like, okay, here is the weight function, and it's this, and so this is basically an implicit closure, right? It sort of it takes the parameter and it passes that parameter to this weight function that came out of the benchmarks. And so then now suddenly this function that was dangerous before is totally benign because we know how much of it we can afford and the user pays for it, right? The weight also corresponds to how much we pay for it. Maybe we can see that here. Can we see that here? Yeah. No, we cannot see it here. Sorry, guys. Anyway, so you pay according to your according to how much weight you're using. So it makes it more expensive to run more expensive calculations on the chain. All right, let's have a look at the chat. Yes, yeah, on a live net, right? This dangerous repeat hashing with the big value, it would crash the whole chain. Because, right, the block, it would try to build that block and it couldn't. Potentially, yeah, no, because it wouldn't know, because the block is valid itself, but you can't execute it, right? Yeah. Okay, so what is the next point that I wanted to talk about? So I'm happy if you have questions about benchmarking, by the way, feel free to put them in the question box. And we'll go on to the next topic, which I want to cover, which is math. Math is a little tricky in Substrate runtimes because of the thing that I will illustrate, and also because math is tricky in general, but also you don't have floating point numbers, right? That's one thing to keep in mind. Floating point numbers introduce potential undefined behavior that's not, or like a different behavior between different executors, and we want the WASM to execute the same for everyone, so we cannot have this sort of undefined behavior, this or the different results, right? Between different nodes, right? Two nodes should always reach the same conclusion, and so for that we don't have float, and we'll have to make do with fixed rational numbers. And then the other thing is that there are different ways to go about addition and multiplication and so on. And this is illustrated in the overflow, no overflow functions. And if you look at them, the difference is here. Right? This just uses straight up normal addition, and this uses checked addition. And it seems irrelevant. And this seems normal. And it is normal, right? In normal Rust, you have the same thing. But one thing is that we are in a blockchain context where we cannot trust that this will be a same value, right? Someone might try to exploit, they might be able to capture value from the blockchain. I think in this case, they would not be able to. But in principle, they could maybe capture value from our blockchain if they manage to introduce a value that overflows. Because the default behavior of addition in Rust is to overflow and then to like to round trip, right? To wrap around. It's a wrapping add. And like in some sense, it should be called wrapping add, not regular add, because it if you reach the maximum value, then it will wrap around. Let's see. I had the tests somewhere. I'm going to open them. Sorry for not having them ready yet. But worry not. We'll get them. I think I have a test somewhere that shows this. No, I don't. Okay, spoilers. We have another thing that we want to cover. Okay, we don't have a test, so we can just show it in the runtime itself. So this value we can set, right? Store something to a big value. So for example, 3, come on. This should be 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 3 billion. Right? And that works. That should work fine, I think. Yeah, something stored is 3 billion now. So if we look at the code, the overflow will now add to this value that we have stored in the something storage. By the way, unwrap or is fine, right? Unwrap or does not panic. It either unwraps or it gives the default value. So that's perfectly fine, perfectly safe. It will just be 0 in case it's not present. So now we have the overflow. And now if we added, I think the maximum value should be like 3 billion something. So if we add 1 billion to this, it should wrap around with this transaction. $4 billion. I got that wrong. So the value, where does it wrap around? Let's see. 2 to the power of 32. 4,294,000,000. Okay, all right, I got that wrong. So then I guess we just add another billion, and then it should wrap around. Right? So now we have a value of 700 million instead of, I think a lot of the time, I personally expect this kind of map to saturate. Like that's often what you want. It depends what you want to do, but often you want to saturate. So the default that Rust defaults to here is not quite safe. So saturating is something that you might expect, or the other thing that you might want is that you will notice when it's trying to do this, right? So let's set the value again to 4 million. Yeah, 4 billion, sorry. And then the no overflow, right? If we try to add 1 billion here, it will tell us, hey, what you're trying to do would overflow, right? Template module overflow, it will tell us that something is up, and it will not do the thing. So, right, so that you can avoid getting unintended consequences, right? In case that you actually do want to wrap, this is fine, right? It's like, just be aware that whenever you see a plus in Rust, implicitly in your head, you should be, this is a wrapping add. So this value might be much less than the maximum value of the type that I'm using suddenly, right? Because it wraps around. Of course, if it's like a queue or something, maybe it's fine. Depends on the use case, but a lot of the time you want to be really, really careful. And then checked add or saturating add are your friend, and that's something to keep in mind. And of course, the same is true for multiplication, right? It's even easier. To reach the maximum value with multiplication. Also, in between, right? If you're doing math for currency movements, right? It's very, very easy to say, like, I'm going to multiply with a big number and then divide by a big number, and then I expect it to be, right? I expect it to be a certain value because you want that, you want to multiply by a rational number, right? So you multiply by a big number, divide by a big number, and that will not give you the result that you expect if you use the wrapping add. I've been going for quite a while already. All right. So there is one last thing that I want to talk about. Unwrap is bad. We already talked about. You know that. Keep that in mind. Unwrap is bad. There's one last thing that I want to talk about, which is transactionality, right? In some sense, some people say blockchains are a database, right? And this is not quite 100% the full truth, but in some sense it's true, right? In some sense it's just a database. So usually when you have a database where you have transactions, right? They're called extrinsics in Substrate, but really, right? Conceptually they are like transactions. And so you usually want it to behave transactionally. Either the whole thing works and the storage gets updated, or it does not work and then nothing in the storage gets updated. So you usually want to have this transactionality, and this is something that you get in Solidity in Ethereum. I think you get sort of for free in some sense, right? If your function errors, then your whole transaction will be reverted automatically, and this is really nice for these end users, but there might be some cases where you don't want transactionality. So Substrate does not force you, Frame does not force you to make your functions transactional. And there is a good reason for this, because one of the things that is not transactional within Substrate and Frame itself is the transaction payment, actually. So here, the weight, right, we get charged for the weight, and this charging happens whether your dispatchable errors or not, right? If we get the overflow error here, that's our fault. We passed a value that's wrong, and so we get an error, and this runtime doesn't care. It's still going to charge us for executing this logic. So in that sense, right, the Substrate transactions are not transactional, because it will charge you, like, but by default, with the way it's implemented, it will charge you irrespective of whether it errors or not. So you might do the same, right? Substrate is meant to be a generic framework, so you might have some extrinsic that is not meant to be transactional, that checks something, it keeps a record. So one particular use case that we've used that I can't illustrate here right now, I don't have the code here, is unsigned transactions. And unsigned transactions, you cannot take the fees to pay for them. So you would you might check and you might do something like check a counter. And if the same account sends the same transaction more than 10 times, you will just block it and not allow that through, right? And the counter you would need to keep track of. You would need to increment that rate limit, right? So so that would be one way in which you don't want them transactional. But for most of the time, when you are writing a palette for a runtime, you want your updates to be transactional. You want to say like, okay, right, I put something in my something, a value in my something, and I put the sum here, and I store it, and then it's either updated or not updated. So so I made these two functions that have the non-transactional sum and the transactional sum, and this is the only change you see is here. So here we first update a value, then we do a fallable action, right? In this case, the addition that might overflow. And then we store the sum that we calculated in storage. And so the only thing that's different here is that we first do the addition, check for overflow, and only if that succeeds, then we store. And then you see from here on out, there's no more question marks that indicate, you know, the return, the error return. There's no more branching here that might lead to us not updating the whole storage. And you can see this in the tests, and this is the thing that's in the tests. Here, right, this transactional sum, it will hold true that it's a no-op in case that it errors, right? And this is a really nice best practice macro that I encourage everyone to use. If you have an extrinsic, you want to make sure that it's transactional, you add this assert no-op, and it will make for the error conditions, and it will make sure that for that particular error condition that the storage was not changed. It checks the storage root and checks that it stays the same, right? And so if we now in this test used the non-transactional sum instead, then the storage would change. Let me see. I wonder whether I might execute this as a test or whether we execute it on chain. I think executing on chain is easier for you guys to see. So let's see. The transactional sum. Cool. So what we do is the following. So we store something. We can store our 4 billion again. And for this, I guess we will check the storage. So we will check the template module and check what something is. It's 4 billion. That's what we put there. We have the sum, right? And so the thing that we want to make sure is that these only change together, right? So if we now use the transactional sum and we try to add 1 billion to this, right, you will see it overflows, and you will see that these don't change, right? If we put a sane value like 1, if we add 1 on top, then the transaction will succeed, and yeah, okay, all right, it replaces the value in storage. I forgot about that. But yeah, you see, right, they sort of change together, right? The sum is here now, and we now have this new value. So let's set the storage again to something, 4 billion. And you will now see that if we use the non-transactional sum, and we try to add 1 billion, which should result in the overflow, and will result in the overflow. You will see that it results in the overflow. Now what you will see happen is that we get the error, and the error would lead us to believe like, oh, this overflowed, this didn't work, so nothing happened. But it changed, right? The value got updated to 1 billion. and the sum didn't change, right? So now we have this non-transactional update where part of the storage changed and part didn't. So you want to be very, very intentional about how you do storage updates in Substrate in order to not run into this issue when you don't want it. Because sometimes you might, but usually you don't. So then one last thing that you might sort of want to use is there is a macro that's called transactional, and that sort of makes your functions transactional by default. Let's see. Maybe it's a good idea to so there is does anyone remember the I forgot the exact URL? Parity-tech.github.io. This is not the browser I normally use, so that's why. Parity. There we go. So transaction. So very much recommended to use this, both the docs, of course, and also this. Oh yeah, latest is the right one, not master. Okay. Yeah, thank you for reminding. This is a technical workshop about building things. Right, this transactional macro, and what you can annotate your extrinsic with it, and then if you the storage changes only get applied if you return OK, and if you return an error, then they will be rolled back, and it will sort of do this, make sure for you that it is in fact transactional. This comes with a little bit of overhead. So if it's a trivial function like this, I would say, do your checks, do this thing, add a test to make sure that it's transactional, and you'll be good. If it's a complex thing, right, and you're building this complex DeFi AMM thing with blah, whatever, then maybe it's difficult to ensure this on your own. And then if it's a more complex or like a voting thing, right, you're building a voting democracy, a palette kind of thing, and it's a complex thing, then feel free to use the transactional attribute to mark the function, and then it will sort of do this for you, and with a tiny bit of overhead. All right, we are at 43 minutes. So I would say we covered a bunch of stuff. I'm going to summarize quickly, and then we're going to go to any questions you might have. There are none in the question box so far, but now's your chance, sort of while I'm talking and summarizing the thing, now's your chance to ask any questions that you might have about best practices for Substrate development. If you want, you can ask a question about how this the stuff that we talked about applies to parachain development if you're curious. I'll leave it up to you. If you don't want to use the question box, you can also put it in chat, whatever, feel free. And yeah, so I'm going to summarize now. So we went through the first thing, which is Unwrap is bad. It leads to potential chain stalls in your Substrate-based chain, which is something that you don't want. There are very, very rare cases, but if you're starting out, just don't use it. As a rule of thumb, if you're starting out, don't use it. Don't ever use it. You can add CI if you like to make sure that whenever you commit something or you merge a PR, there's no unwrap in the palette code, because there shouldn't be. And if you really are sure that it always has a value, then you can use expect, and then you provide some proof in the comment there why it can never fail, and then you'll be proved wrong or right depending on whatever. The next thing is benchmarking and weights. It's important to, one thing that I did not say, but that I want to emphasize here again now, is you need to test the worst case for benchmarking, right? Maybe it would have been good if I had an example that illustrated a benchmark that is not worst case, I have seen this before. Mea culpa, sorry for not illustrating this as well. Maybe you can figure this out yourself. Take-home exercise for you. To write two different benchmarks. One is not a worst case. The other one is a worst case. So one way I could make this not worst case, right, is if I just assume the parameter is a certain value, right? If I just assume it's 5, then it's not worst case. That would be a trivial way, maybe. So the benchmark needs to be worst case, needs to cover that, and needs to sort of give representative values for this worst case. And then based on that, you can run the benchmarks, you can generate weights that you can then use in your runtime. Another thing I didn't say that I also want to repeat, that I also want to say is these benchmarks and these weights are runtime specific, and they're specific to your hardware, right? So you need to make sure to decide what hardware do I expect from my validators. Of course, right, you can use the ones that Polkadot uses and take those as representative. That might be a good default, but you still want to think about it, right? Oh, do I have the same requirements for my validators as Polkadot does? Or maybe others do, right? Like maybe other teams in the ecosystem also have their own benchmarking machines, specs that they recommend. So, right, what machine do I expect this to run on? Which database, right? We covered the database stuff. Which database is it going to use? And then what runtime? So you run the benchmarks for the runtime, because there might be interactions between the palettes. That's a complex topic we can go into, but whatever. So there might be interactions, so you always run the benchmarks for the whole runtime, and then you can you get some resulting weight files like this, and you can sort of plug them into your runtime. You'll notice, right, this is in the runtime here. This is not in the palette. Of course, you can give some defaults for your palettes and so on, but let's not go into that. So it's important to benchmark and generate the correct weights. If you don't, then you should, basically you just should do that. If you have done development for a while and you have a feeling for, right, like based on running this benchmark here with the 26 million and me being able to look at this and see, rule of thumb, this should not be much more expensive than 10 million and a write, right? You can improvise this. You will see this in Polkadot sometimes where it says like, we just say this is 1 billion in weight and hope, and we're pretty sure, if Gav says that something is probably 1 billion weight, it's probably not going to be more than that, and then you're safe. If you overestimate, right, be safe and overestimate. But if you put something into production, like prefer to actually benchmark and generate weights. This can keep your chain from stalling. Then math is a little bit tricky in the runtime because the default add is a wrapping add, so it wraps around. This is often not what you want, so you want to usually either have some clear indication that this will never overflow. So if you, for example, that this instruction can only be included once in a block, and you have a U32, then you know that you have 4 billion, whatever, right, the number was, blocks, and you can calculate, okay, that's going to last me a few hundred years, then it's probably fine, right? But in general, you want to not use the wrapping add and instead use checked add or saturating add to make sure that you don't overflow unintentionally. Unwrap is bad. And then we have the transactionality. Usually when you have these transactions, these extrinsics in your palettes, you want them to be transactional, so either all or none. And you can assure yourself of this by having tests that assert no-op on all errors, all error cases that you have. You can do an assert no-op for that error case. If you've covered all of them, you can be fairly sure that your function is transactional, and you can uncover issues like the one that's present in this particular code. If you choose a function to not make it transactional, be very, very mindful about that. And if you want to just, you have a complex function and you're not sure how to make it transactional, you can use the transactional macro. That was a long summary and also pretty fast, probably. All right, I think I'm good for now, and we can move over into questions. Thank you for your time and attention, and let's head over to the questions.
Yeah, So yeah, uh, I guess someone was just trying to check in to, why Unwrap is actually bad. Because it seems that it's quite commonly seen in a lot of places in Substrate. So maybe you would like to just explain a little bit further on that before we just kind of wrap up today's session with some hackathon information.
So it's bad in the runtime, right? Maybe I should have said this more explicitly. So you will not see, I don't think I know of any places in Substrate or Polkadot where we have Unwrap, direct Unwrap in the runtime. What you do see is Unwrap or Unwrap or defaults or Unwrap or else or kind of things. They're different. They do something else. They don't panic. And what you see is expect. And expect is for places where the it would panic if it weren't there, but you're so sure that it will not happen that you're willing to run that risk. And then you say like expect, and then it says like this value can never be none because I initialized it 2 lines above or something, right? And then actually can github.com/check. Oh, I don't get search if I'm not logged in. Okay. Okay. I don't have search. It seems. Do we have something? Jimmy, maybe you remember where we have an expect in the code. I'm not sure. We probably have lots of places where but like I would be very, very surprised if you could find any unwrap in the Substrate runtime or in Frame Substrate runtime or Polkadot runtime code. This should not be there. And the reason it's bad is it will panic. The panic will fail the transaction one, which I guess is good, but will halt the execution. And this is dangerous because you can DDoS validators with this, right? The validator will sort of panic the thing. It will take some computation time to sort of clean up the thread that the runtime was running in, and this costs resources, and you don't pay for it at all, right? Like the panic means that there's no payment, nothing, and you need some logic to make sure that the transaction is not included in the block and so on. And then the other thing which I showed is your chain can stall. If this happens in the uninitialized block, your chain will stall and you're screwed. So don't do it. I don't know. I'm not sure if you can make it more precise why you think it's fine. Then I can try and argue against that. But yeah.
Okay. All right. Thank you, Alex, for sharing today's session. I hope that for those who have actually attended today's session, get a little bit better understanding on what to avoid when building on the palette, and what some of the best practices. Of course, feel free to reach out to Alex, and the rest of the mentors who are on the Discord channel as well. They'll gladly answer any questions that you have, especially when you are building a project for the hackathon. So probably let me just share my screen now. I'll just cover some of key information about the hackathon to just sum today's session at the end of the day as well. So over here, we are part of the Polkadot Hackathon, which is the Asia Pacific edition over here. And I'm pretty sure all of you have more or less known that there's actually 3 categories for the hackathon itself, namely build a blockchain, open track, and for open hack. And for those who are better at writing how-to guides or tutorials, a Docathon will be something that will be more suitable for you as well. Moving on, some of the key events that will be happening for the next 2 weeks as we are leading up to the last leg of the hackathon. We do have a hackerspace, which is a virtual space where you can come in and meet your teams and also meet the mentors as well during the mentor office hours. And it's free for you to come. So do utilize this opportunity to meet with your mentors, to ask any questions that you have with regards to your project as well. Of course, we do have our last technical workshop that's going to happen next Friday. And do join us. It will be led by Ben, who will talk a little bit more about the Polkadot ecosystem, how you can be part of this ecosystem in general. So the mentors who have availed themselves both on Discord and Meta Office Hours will be there to assist you in any aspect of building your project, be it on the blockchain, OpenHack or Docathon. You can always direct them the questions that you have to the mentors as well. A few ways that you can meet them. First of all, as I mentioned previously, it will be the Meta Office Hours that will be happening and taking place on every Wednesday at the virtual hackerspace, which is hosted on Gather Town. On top of that, you can actually reach out to these mentors on the Polkadot Discord channel under the Polkadot Hackathon Asia Pacific. You can actually reach out under the Hackathon Technical channel, but if not, you can always choose to DM the mentors that are listed over there as well. So Polkadot Pathway is also available for you to earn rewards apart from gaining points and learning. It's also an opportunity for you to practice how you can build on Substrate itself. And of course, the top 50 will actually win yourself a hackathon swag. So, why not? If you can kind of like get something for yourself at the end of the hackathon while learning at the same time. So let me just cover some of the submissions portion now that we're on the last part of the hackathon. Basically, for Build a Blockchain and OpenHack, all projects are judged based on 4 categories. One would be impact and usefulness. The other one will be the originality of the project. Next will be the technical complexity. And last but not least, the user experience while you're building this solutioning as well. The Docathon, on the other hand, will be judged based on the clarity of the documentation that you're writing. What are the examples and resourcing that you have done while you're writing the how-to guide or tutorial, the goals and use cases, and last but not least, the overall to tell us what's the objective that you'd like to meet for this Docathon track as well. As for submission, for those working on building a blockchain and OpenHack, do remember these are the important artifacts that you need to submit, which also can be found on the participant guide, but mainly it needs to have a GitHub repo link with a README, a pitch video, a list of tech stack, and if the solution is deployed, you can also submit your demo link as well for the judges to actually assess it. For the Docathon, on the other hand, just make sure that you point to the project that you are making the documentation for. And please note that it has to be a Polkadot related project. Definitely a GitHub repo link that includes any the links that redirects to where all your documentation are actually hosted so that the judges can actually make reference to as well. So just a reminder, submission is going to be on the 12th of December, which is going to be 11:55 Singapore time. And for those who are at CET time zone, that will be around 4:55 p.m. on your time. And for those who are based in India, that will be 9:25 p.m. your time. Basically, key things that you need to take note of is that you can't submit projects that's not done by you for sure. To those if you're using any existing projects and make sure that you check out the license of any public repository as well. Last but not least, what you will be marked against will be what you have written during the hacking period, which is the 22nd of October to 12th of December as well. For those who have team members who have just recently joined you, one thing that I'd like to highlight is that all members needs to be registered for the hackathon in order for the team submission to be qualified for the prizes. So for those who have not yet registered but belong to a team, please make sure that you can actually scan the QR code to register. But if not, you can get your team member to actually send you a link that has been sent to their inbox the moment that you have registered as well. You can use that to register. On top of that, for those who are really participating in the hackathon, just a reminder that you can always refer to the hackathon calendar, which you can download it via the participants guide, which apart from the technical workshops and Meta Office hours, there will also be reminders on when submissions are due. So it's a great opportunity, a great way to remind yourself while you're working on the projects as well. And lastly, go ahead and go to the Polkadot pathways to get yourself more better equipped with knowledge on building on Substrate as well. So key people that you can take note of, you can reach out to myself, Justin, and I'm on the Discord channel as well, Urban and Jimmy, who will be from Web3 and Parities, who will answer any hackathon related questions. And of course, if you have any technical questions, do ask any of the mentors, including Alex today as well, who will be answering any questions that you need as well. So that's more or less it. We are just nicely on the top of the hour. Thank you all for taking time to join us today. And I really appreciate all the participation and engagement so far at the hackathon. We are down to about 2 weeks left. So all the best to you, and hope to see all the submissions that will be coming in. Thank you, everyone.
Bye.